Hello everybody. This is the presentation for dark light board testing RC circuit. So here I have a little code that I wrote by myself and with help of my teammates Rosette and Cristina. Um, it is a simple code that just tests the different frequencies for output and for output signal in the dark light, and then for the input signal that we receive, and just see the different phase angles for them. So as you can see, it's not that big. So let's run and see what it does in general. So first thing first is it asks us for the resistor value. The resistor value I'm using right now is 1000 ohms. Capacitor value is 100 farads, but it says that it's in microfarads already, so I'll just put in 100. Maximum frequency. Well, let's go at 1000 hertz. Just a random number as well. Well, don't forget it's the maximum of 10,000 you can put to the dark light itself. So please type more to increment the frequency. So I'll test for different frequencies and I'll increment each time. So let's do it by 200. And the code starts straight away. That's the first signal that I've sent and received. That's the second one, and all the signals are being plotted on the main figure down there, if you can see it. I'll show it later when I reach all my 6 states. So see, that's the 5th state, or that's the 5th signal that I've sent it to it, and that's the last one. Let's see what we've got. So we've got 6 different signals that I've sent and received from the dark light. So first one is at 1000 1000 samples. It is 1000 samples at 1000 hertz, which makes it 1 second. And basically all my signals are 1 second. Or to be clear, they are twice as big as 5-time constant. 5-time constant is the time that takes for the signal to level out. So it just happened that my 5-time constant value is half a second, and if we just multiply by 2, which makes it 1 second. So all of my signals are 1 second. That's first column. Second column is I'm getting the frequency response of my send signal, or red signal down there, and it is pretty intuitive, which it will be 127.5, because that's the amplitude of our signal, which is 255 bits highest and 0 lowest. Second column, or the third column, is frequency response of the signal we receive, which is the blue signal down there, and they are getting smaller as you go on, see, and they do get smaller. I can just show in here that this value is about 28, I guess. Yeah, see, it's about 28, and it will get smaller because our amplitude of the input is getting smaller. So yeah, you can see it's just on 10, if I'm not mistaken. Yeah, it is on 10 or 11. Okay, let's leave it. The last column fourth column is our one cycle of the input, which is related to the signal that we send. This is basically getting the phase different phase angles. So I will show you the code in a second. Basically, what it does is just takes the, for example, the highest value of the blue signal, which is our input signal, which we receive, and the highest of the output, output signal, the one we sent. I get the maximum value of this at a specific index, and then I just minus the indexes, multiply them by, or divide them by the total sample rate, which is basically the number of samples that takes for one cycle to complete, and I multiply it all by 360 to get the degrees. Well, that's what it is. Now, just have that in there. Let's see the code. So I just ask for the input value. That's 5 time constant. You can read the comments yourselves later if you don't understand anything. I'm asking for the input, or for the frequency. Again, for the frequency incrementation, the amount of frequency I increment each time, and this is where the main code starts. What we are interested in is the phase angles. So let's go to that bit. That's the bit where I check for the maximum value of one cycle, that the signal that I'm putting in, and the maximum value of the signal that I'm reading, which it is basically reading signal. So and I get the indexes of this, and I just name them I and I2, the indexes. So, and that's the main phase change, or phase angle change. So see, it's just the absolute value of index 1, which is the maximum of input, and index 2, which is the maximum of cycle delta, which is index is just a number, the nth sample. So yeah, I just divide out by the total number of samples in the cycle, and multiply by 360, and I get the value. And next line is just getting the theoretical value, or the value from the equation. And I printed out as well after each sample I run, basically. So you can actually see that the calculated phase change by formula was 89, which we can see it's the last one that I'm reading, which is, you can clearly see that the highest amplitude of the blue, which we are reading, is about half of the sinusoid, half of the signal we're sending. Which, you see, it is half, basically. So it has to be 90 degrees out of phase. What I get for the value of the phase angle by graph is 81. It is a bit low, but I can explain why. Basically, my signal that I'm receiving is a bit smaller in the amplitude, so I cannot read it values very clearly. And you can see, yeah, the maximum value is just like a line down there, which is the maximum value. What my code does is takes the very first index of the maximum value, which will be 100, and I'll show it down there, which is like it is 102, as you can see in there. Yeah, somewhere. Uh, yeah, more clear. Or even sorry, it's 90. It is 99 point something, 99.5. Uh, Instead of actually getting the average value of our highest. So uh, that's why I'm getting low values down there. You can see another value, 76, which was probably the index was a bit earlier than it should. Uh, I always get one very high value for phase angle by graph. That's because it's the third one. That's because my value, my maximum value uh, is a bit off. So basically, I can explain it now what it is. For the input we're reading. See, the highest value is approximately there, which makes it equal to, I guess, about 15 or 10. But it starts at 0. The maximum value starts at 0. While the maximum value of the sinusoidal we are sending is at, well, I'd say at 130. So, see, that difference is too big, and eventually we'll get too big phase change. I didn't have any check for such an error in my system, but it's only one value out of the six. Out of six sinusoids I said. So see, that's the third sinusoid, that's the second sinusoid, and that's the first sinusoid I'm sending. Um, so yeah, that's my little presentation for the dark light. But also, uh, there will be a code submitted along with this video on web courses, and as well uh, in the video, or on my drive, Y drive, not the Y drive, Google Drive, sorry, which I'm gonna send the link. I'm gonna mention the link in the description. So just read the description, and you're gonna find everything you need. So thank you, and thank you for listening, and hope you enjoyed this.